Hello dear students, everybody welcome to channel Sube. Today we are going to discuss the question number 34 of 2020 physics MCQ paper. A hot object hung in a room at 30 centigrade takes 5 minutes to cool from 60 centigrade to 50 degrees of centigrade. What is the time taken by the object to cool further from 44 centigrade to 36 centigrade under the same conditions? 10 minutes. There are answers given. We can solve this easily using Newton's cooling law. We just draw a little sketch of the incident. They have given the room temperature is 30, so we just write it here, 30 centigrade. That is room temperature. Therefore we denote it by theta R, room temperature. Here the initial temperature 60 of the object, then it cool down to 50, then from 44 to finally 36. This is the story. From 60 to 50 the time taken is 5 minutes, so we use minutes here. We don't have to convert it into seconds because answers are all given in minutes. Then from 44 to 36 they ask the time. They don't know the time. We also don't know. We have to find it. Take it as t. What is the time taken by the object to cool further from 44 to 36? So that is what they want. So here we have to mark this like this, because first it has to cool down from 50 to 44, then 44 to 36. This part of the story, first for that we write equation. For A we say A. For that portion of the total incident we are going to write Newton's cooling law. What is Newton's cooling law? dq over dt is proportional to excess temperature theta minus theta r. This temperature is called excess temperature. Additional temperature of the object than the room temperature surrounding. But we don't know anything about Q. What is Q? Q is the heat. Q is the heat, amount of heat. But no data is given about heat. Only temperatures are given. Therefore, we have to change this equation a little bit. We know Q equals ms theta. Q equals ms theta. Then we can write dq. dq is the specific amount of heat used for this incident, and d theta is the specific amount of degrees increased or decreased in this incident. So divide by dt, that means we take the rate, that means the quantity of heat per second, the amount of degrees per second. We can take like this, dividing by dt. So dq divide by dt part is here. Here also dq divide by dt. So since this thing is constant, it doesn't change in this phenomena, in this incident, it doesn't change. M is same, then specific heat is same, so this one is constant. Therefore we can use this one instead of this one. because dq over dt is proportional to d theta over dt. We can use this thing instead of this thing. So that is what we are going to do now. We are going to substitute d theta over dt to this dq over dt. Then we write d theta over dt equals k is the proportional constant, theta minus theta r. You don't have to do all these things in the exam. I am doing this for your sake as a lesson, because otherwise people who don't know this lesson properly will not understand this. Then it is useless. It will be useless, this lesson. Therefore I explain all these things, but you have to just directly, you can write this thing in the exam, real-time exam. So we substitute the values here now for the portion A, for the part A. D theta first. What is d theta? D theta is the difference of these temperatures, 60 to 50. That is d theta, difference of theta. D is difference. So 60 to 50 is 10 degrees. 10 here. What is dt? Dt is the time difference. Time. So time is 5 minutes. We don't have to convert it to seconds, as I said earlier. Then k, that we don't know. What is theta here? You remember, this theta is mean value. Why? Here theta is not constant. Mean temperature. Here to use mean temperature. Not 60, not 50. It didn't stay in 60. Neither in 50. It changes like this. Temperature decreases. Therefore, not 60, not 50. The center value, the mid value, what is that? 55. Not 60, not 50. 55. The mid value is 55. Otherwise, you can calculate it, but actually you don't have to do it. You can take it as I took it here, like here. So how do you do it in mathematics? First value plus second value. So there are two numbers, two items, divide by the number of items, two items. Then you receive 55. That is how that should be calculated, but easily you can do it as I did, the way as I did. So mean value, then 55 here, minus theta r is the room temperature. It is given 30 centigrade, 30. Now you have to simplify this. 30, 40, 55, 25 here, k here 2, 10 divided by 5. Then k equals 2 by 25. You don't have to simplify this, just stop it here as it is. And now we are going to do the same thing to this part of the incident, part B. Part B, d theta over dt equals k times theta minus theta r. What is d theta here? 44, 36, in between how many degrees? That is d theta. 36, 40, 44, 8 degrees. Divide by dt. What is it? Time. Time we don't know. That is what we have to find. Just we write it as it is. Then k we know, 2 by 25. 2 divided by 25. Then theta is the big thing. You have to take, you have to find it. How? The center value. Not 36, not 44. 36, 40, 44. 4. Here 4, here 4. The center value is 40. Center value is 40. That is the mean actually. So you have to take 40 here. 40. Then in brackets 40. Room temperature is still 30. Then 10 here. 10 into 2. 20. Divided by 25. 8t. Then 4 times, 5 times, 4 times, 1 times, 2 times. Then t goes this way, t equals 5 goes this way, 5 times, 5 2 times, then 10. T equals 10 minutes. That is the answer. That is the answer. This one. First one is the answer for this question number 34. So thank you very much. I think you understood well. This is not a big issue actually. These types of questions we solve normally in the classroom under this topic, Newton's cooling law. So if you have done exercises well in the classroom, you could have done easily. You could have solved this problem easily. So I think you understood well. So thank you very much for watching this video. Please help us by subscribing the channel. You have to spend nothing. We have to do a lot of things in future. We will help you. Thank you very much. See you soon. Have a nice day.